Hey guys, this is Mrs. Lyons. This video is going to go over the bond polarity practice that was assigned for homework. So we're going to draw these Lewis structures and then determine the bond polarity. Alright, so I'm going to go through these structures kind of quickly because we should be getting good. Nitrogen has 5 valence electrons. Hydrogen, we have 3 hydrogen. Each hydrogen has 1 valence electron. So we're going to connect those dots, and there's our molecule. All right, now if you look at your electronegativity table, let's see, nitrogen is 3.0, and hydrogen, I'm just going to write 3.0, hydrogen is 2.1 on the electronegativity chart. So that's a difference of 0.9. So remember, here are our values. Over to from 0.5 to 1.9, and then from 0 to 0.4. So this first bond at 0.9 would be a polar bond. All right. SiO2. So silicon has 4 electrons. Oxygen has 6. So our structure is going to have a double bond. So this is actually going to be a bond also. And then I'm going to cross these out. Okay, so I'm going to go ahead and redraw this just because I'm a little picky about it. Okay, so silicon dioxide. So let's look at our bond electronegativity. So silicon has an electronegativity of 1.8. Oxygen is 3.5, so that's a difference of 1.7. So a polar bond. CBr4, carbon, 4 valence electrons. Bromine, 7 valence electrons. Alright, and then I'm going to connect the dots. Okay, so there's your Lewis structure. Carbon, we know, is 2.5. Bromine is 2.8. That's a difference of 0.3. So this is non-polar. All right. BiH2. So we've got boron, which has 3 valence electrons. And then we have an iodine and 2 hydrogens. So I'm going to, let's see, hydrogen each has 1, so I'm going to connect those. And then iodine has 7. So it's going to look like this. All right. So now we've got 2 different bonds to look at here. We've got the boron-hydrogen bond. So let's see, boron is 2.0. Hydrogen is 2.1. And iodine is 2.5. All right, so that means the boron-hydrogen bond would be 0.1. So that would be nonpolar. And the boron-iodine would be 0.5, which would make it just a little bit polar. All right. N2F4. So we're going to put the 2 nitrogens in the middle. Nitrogen has 5 valence electrons. And then we've got 4 fluorines. I'm going to put 1 by each of my solo electrons. And then fluorine has 7 valence electrons. All right, now we're just going to connect our dots. like so. So there's our Lewis structure. And then for polarity, we're looking at nitrogen is 3.0 and fluorine is 4.0. So nitrogen fluorine is a difference of 1, so that's going to be polar. And then we have this, excuse me, we have this nitrogen-nitrogen bond, which is going to be nonpolar, because when you have the same atom, the electronegativity is the same, so you don't have to, it would be nonpolar. Okay, one more. So we've got nitrogen, oxygen, hydrogen. So nitrogen is going to be in the middle. And then I'm going to put an oxygen on one side, a hydrogen on the other. Hydrogen has 1 valence electron, oxygen has 2 or 6. So we've got 2 bonds that can be made. I'm going to write this a little bit neater. So hydrogen bonded to a nitrogen, and that's double bonded to an oxygen. You stop that now. No more. No more. No. Okay, so we end up with this as our structure. All right, so then we have a hydrogen-nitrogen bond. So hydrogen is 2.1. Nitrogen, we said, is 3. So that's a difference of 0.9. So nitrogen-hydrogen is going to be a polar bond. And then nitrogen-oxygen. Nitrogen is 3. Oxygen is 3.5. So 0.5 difference. So that is also going to be a polar bond. All right. So I think that is it for bond polarity. What we're going to do next is we're going to look at molecular geometry, the shape of things. So I hope this video was helpful. I will see you in class. Take care of yourselves.